Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Okay, this is the final subtopic for the chapter 2, which is divergence, or also known as Gauss theorem. Alright, let us start with the definition. Gauss theorem or the divergence theorem says that the total expansion or magnitude of a vector over the region inside the three-dimensional surface is equal to the amount of a vector flow through some closed three-dimensional surface. So if you still remember, the total expansion or magnitude of a vector can be found by using divergent F. While because of we want to know the divergent f over the three-dimensional surface, we can apply the triple integral. Okay, so means that the triple integral of the divergent f over the three-dimensional surface can obtain the total expansion or magnitude of a vector. While on the other hand, the amount of a vector flow through the surface can be obtained by using surface integral for each surface. So in this case, what the Gauss theorem says that the triple integral of a divergent f of the three-dimensional surface is equivalent to the surface integral of each surfaces. Let's say I have here a cylinder which consists of three surfaces. So means that the triple integral for the whole cylinder is equivalent to the f dot n of S1, f dot n ds for S2, as well as f dot n of surface 3. Okay, we have to add all together. So we can summarize that the divergence of Gauss theorem is equivalent to the triple integral to the divergent f dv equal to f double integral f dot n ds. One thing that you have to remember is about the normal vector. Okay, normal vector of the surface has to be always in outward orientation. Okay, outward also can be upward. Okay, it also can be downward. Okay, as long as it is outward, out from the surface. Right. This is comparison between Green's theorem, Stokes theorem, and Gauss theorem. We have learned before Green's theorem, where it's involved the plane in two-dimensional surface, while Stokes theorem we involve three-dimensional surface. Now Gauss theorem it also involve the three-dimensional surface. However, Green's theorem and Stokes theorem has similar concept where it relates line integral and surface integral, but now Gauss theorem it's relate surface integral and volume integral. You can see here I have three example for Green's theorem. It's always involve two dimensionals. For example, a circle. So you can see the line integral of the C, which is the curve bounded the circle, is equivalent to the surface integral of the S, which is the region inside the curve. Okay, inside here. While for the Stokes theorem, we can say we have, let's say here, a paraboloid. So line integral of the C here is equivalent to the surface integral of the S in three-dimensional perspective. While for the Gauss theorem, we can see that the surface integral of the surface 1, here we have surface 1 plus with the surface integral of the surface 2, which is equivalent to the volume integral of the whole paraboloid. Okay, that's this comparison you should understand very well. Alright, I have one example here. Verify Gauss theorem for f equivalent to xyj plus zk, whereas the surface given by the parabola z equal to 4 minus x squared minus y squared with z equal to 0. I hope when you see this equation, you already recognize it where this is a paraboloid with z equal to 0. So this is the paraboloid. So we can see that we have two surface involved in the paraboloid. Surface 1, let's say I put z equal to 4 minus x squared minus y squared as the surface 1 and z equal to 0 as the surface number 2. So we can see that in order to verify this Gauss theorem, you have to show that the double integral of the surface 1 plus to the double integral of S2 is equivalent to the triple integral of the divergent f of over the whole parabola. Alright, so this question asks you to verify. So let us start to do the divergent f first. So first of all, find the divergent f. You should remember how to find divergent f, which is del over del xi plus over del over del yj plus del over del zk dot with the f given in the question. So you should have a scalar function x plus 1, a scalar function x plus 1. Now you can proceed to integrate it, but you have to remember, because this is a parabola, you have to apply polar coordinate of cylinder, because you want to do the triple integral. So you have to make sure you use the polar coordinate of cylinder. Okay, because as stated here, parabola has height, which is provided by the z-axis. You have radius and you have angle. So the only polar coordinate can apply it, which is the polar coordinate of cylinder. So convert everything. X plus 1, x is equal to r cos theta. So r cos theta plus 1, where dv is r dr d theta dz. So determine the radius theta and also the z, where the radius is 0 to 2. I hope you understand how to obtain the radius by where we have here z equal to, I think I have here z equal to 4 minus x squared minus y squared. Okay, and then we have z equal to 0. So you substitute, you solve simultaneously. So you have a circle equation, x squared plus y squared equal to 4. So which means that you know that the radius is equal to, so radius is 0 to 2. The theta is 0 to 2 pi, which is because of this is a full paraboloid. Okay, so 0 to 2 pi. And then z is 0 to 4 minus r squared. How I got this? Because we know that the lower limit is z equal to 0, and it goes to upper limit z equal to 4 minus x squared minus y squared. So the limit of z will be 0 to this equation, z equal to 4 minus x squared minus y squared. Then convert it to polar coordinate. To simplify it, so we get 4 minus r squared. And you have to remember, for this is a special case for parabola, you have to rearrange the limit so that make it z to be the first limit. Okay, so that your equation will be correct. Okay, so your integration will start with the limit of z goes to limit of r, or goes to limit of theta. You can do theta first, it's up to you, but you have to remember z has to be number 1. Alright, now proceed with the other side, which is f dot nds. We have two surfaces altogether. So let us start with the surface number 1, which is z equal to 4 minus x squared minus y squared. First step is you have to find n. Okay, find n. So in this case, normal vector of the z equal to 4 minus x squared minus y squared, as I mentioned before, the normal vector has to be outward. So it means that here, this normal vector for the normal vector for this surface is upward. Okay, so based on the table 2.4, okay, table 2.4, because n is upward, so means that it's positive orientation, and the s here, which is 4 minus x squared minus y squared, is non-parametric surface. So the formula will be negative del z over del xi minus del z over del yj plus k. So you partial differentiate z respect to x, respect to y, and you put into the function, into the equation. So you get 2x plus I plus 2yj plus k. Now after that, you do f dot n. F given in the question is xyj plus zk dot with the n that you obtained before. So you have a scalar function xy squared plus z. Because you do dot product, you have to remember the answer should be in scalar function. And then you proceed to do the conversion using polar coordinate of plane, because we want to do the double integral. So means that you convert it into two dimension. The easiest way that I mentioned before, the easiest way to do the surface integral is convert the paraboloid to be in two dimension. So you can see you have to apply polar coordinate of plane, because in two dimension you have a circle consists of radius and also the angle, radius and angle only. Okay, so now x is equal to r cos theta, y equal to r sin theta. So convert everything, and z equal to 4 minus r squared, which is the equation of the surface. So now you have 2r cubed cos theta sin theta plus 4 minus r squared. Now you going to integrate it. So radius is obviously 0 to 2, theta is 0 to 2 pi. Okay, how about the other surface? The other surface is z equal to 0. Okay, now you find the normal vector. So obviously the normal vector is downward. Okay, so n is downward, which is s is also non-parametric surface because z equal to 0. So based on the table 2.4, okay, so we have the formula of del z over del xi plus del z over del yj minus k. So you partially differentiate z equal to 0 respect to x, respect to y, you got 0, everything. So you just have negative 1 here. Okay, 0, 0, negative 1. Alright, then find f dot n. You do f dot n, and then you get negative z. However, based on the equation of the surface that you have before, which is z equal to 0, so means that your f dot n is equal to 0. So integrating 0 ds, of course you get 0. So means that s1 and plus plus with s2 is equal to 8 pi, because s1 is 8 pi, s2 is 0, so we got 8 pi. Alright, so just now we have verified the equation, verified the Gauss theorem. Other than that question, other than the verified kind of question, just now we do the verification. The question also can just ask you to use the theorem. Let's say for this question, you have to use Gauss theorem to evaluate f dot n ds with upward orientation. So means that you have to do the other side, which is divergent f dv. Remember, use Gauss theorem. Okay, you have to remember this. Use Gauss theorem to evaluate f dot n. So means that you have to do triple integral divergent f dv. On the other hand, if the question asks you to use Gauss theorem to evaluate triple integral, so you have to do double integral f dot n ds. Okay, so you can have three types of question, as in example 1 just now. Example 1, you put the question asks you to verify, so you have to do both. The triple integral is equal to the double integral. You have to show both answers are correct. And then the question also can just ask you to use Gauss theorem to evaluate f dot n ds. So you have to do triple integral divergent f. And also question can ask you to evaluate triple integral divergent f. So means that you have to do the double integral f dot n ds. If let's say question doesn't mention to evaluate which part, you have to use your understanding. Okay, if let's say you think that the double integral is easier to solve compared to triple integral, so you can choose based on your understanding. Okay, so please do exercise. Inshallah it will help you. Any question you can contact me. Okay, thank you from me. Assalamu alaikum.